So in this particular question, we are told that we have a car and a bicycle that are equal distances from a crossroads. Okay, the car is traveling north with a speed of 15 meters per second, and we have a bicycle that is traveling east at a speed of 5 meters per second. Now, at this instant, which arrow represents the velocity of the bicycle relative to the car? Okay, so relative to the car. Now, a quick way to do relative velocity questions is to imagine you are in the car, or in other words, okay, the car is apparently stationary. Okay, I want you to imagine that the car is apparently stationary. So if you are in the car, okay, you don't move relative to the car. So if you are in the car, it appears as if the bicycle, okay, on one hand, it appears as if the bicycle is moving towards the right at 5 meters per second. But because the bicycle is also approaching you, all right, remember, the car is apparently stationary. Because the car is apparently stationary, it appears as if the bicycle is approaching you. So your velocity of 15 meters per second is transferred to the bicycle. So the bicycle is going to be approaching you at 15 meters per second. So as a result, what's going to happen is that the bicycle will have a resultant apparent velocity that is along the diagonal like this. All right, you can use Pythagoras theorem, all right, if you really wanted to find out what the magnitude is, okay. But the general direction is going to be in this particular direction. Okay, so our best answer for this is C. Now, the technical way of doing this particular question is going to be, all right, we take V2 minus V1. So V1 is the object, the reference object. V1 is said to be the reference object. Okay, so in this case, V1 is said to be the car, and V2 is said to be the bicycle. Okay, and if, let's say, the y velocity of the bicycle, of course, we know and we can see that the y velocity of the bicycle is 0 meters per second. Okay, and we have the velocity of the car, which is positive 15. All right, I'm taking upwards as the positive direction. Okay, so the y velocity of the car is positive 15. So we have 0 minus 15 meters per second. So this is going to be negative 15 meters per second. So this is the velocity of the y velocity of the bicycle relative to the car. And since this is negative 15, we can see that this is traveling south, all right? Okay, because we define this direction as positive. So the y velocity of the bicycle is said to be negative 15 meters per second. Okay, and this gives us the exact same result as before. Okay, we have the relative velocity of the bicycle, which is pointing downwards at 15 meters per second. All right, and we have a rightwards velocity of 5 meters per second, and the general direction, the resultant direction, is going to be pointing roughly southeast.